Well, within Tyndall we have what we call Flexifab, which allows you to bring together different materials into a wafer fabrication line that traditionally wouldn't be allowed to mix. We have in place protocols and procedures which allow careful control and careful handling of these different materials. So for example, you're working with CMOS and you're working with compound semiconductor, you're working with magnetic materials and copper on silicon wafers, and you're working with gold materials with CMOS as well. So you have to be very careful in bringing these materials together. And this is quite a unique capability to have within a wafer fabrication facility. We are fabricating things like magnetic materials onto silicon wafers to make future devices that reduce power consumption in consumer electronics, for example. And that requires you to mix and marry together things that you wouldn't normally have in the same fabrication. Additionally, we're looking at ways of integrating chips together. So we're looking at what you call heterogeneous integration through one of our spin-in companies, Accelerprint, where we're bringing together their capability in transfer printing, if you like, of chips onto wafers. So you can have devices made of indium phosphide being intimately integrated onto a silicon wafer to give you a function that you wouldn't be able to achieve any other way.
Tyndall's unique Flexifab infrastructure enables wafer-scale integration of nanomaterials. We've developed nanoelectrode platforms for electrochemical sensing with applications in precision agriculture, food and the environment. We've also developed low-power transistors by integrating 3,5 germanium and 2D layered materials onto silicon. We grow and integrate new photonic materials for energy-efficient lighting and high-speed optical communications.
What is unique within Tyndall is we are what you would class as being vertically integrated, which allows you to go right from the concept phase through to the modelling and simulation, to design of materials, to fabrication of the materials, and then you take those materials and you can make devices from those materials you made. We have the capability at both the front end, which is the wafer fabrication. We also have capability at the back end, which is extremely valuable. Now in the back end capability, that's typically where you would take a completed device, you would package it in a way that the user can actually apply it in their product. So there we have things like our photonics packaging, and we have our electronics packaging, which gives you the capability to package your photonic chips with optical fibers, advanced guide wires, all sorts of things which would fit different market sectors. And also in the electronics, we can package up the electronic chips to allow for high-speed test and measurement and other things of that nature. Within the back end, we also have the device forensics, which allows you to take the materials or the chips or the finished packaged devices and reverse engineer them to allow you to find out what worked well, what didn't work, which you can then feed back into the design and simulation to allow you to rapidly home in on what are the most beneficial or most promising candidates to produce the finished product.
We have a large set of integrated circuit design capabilities here in Tyndall. Here in this lab, we specifically focus on system-on-a-chip design of RF transceivers.
In the future, you're going to need to be able to integrate a lot more things together, both devices and materials, to give you the types of integrated systems for ICT. As I mentioned before, the Tyndall unique selling point is we have the capability to allow you to bring together different materials to realize these different products, and having the vertical integration in terms of being able to go from modeling all the way through to fabrication, packaging, system tests gives you that complete supply chain under one roof, which is extremely valuable for the customers and their research engagement.